In this lesson, we are going to talk about how to find more refined confidence intervals for proportions. So first, let's get a basic idea of what a confidence interval is. So a confidence interval is an interval of values that are computed from sample data that is likely to include the unknown value of a population parameter. For example, what is the proportion of the population that suffers from allergies? What is the proportion of the population that supports Donald Trump? And what is the proportion of the population that supports Hillary Clinton? All of these things can be addressed using confidence intervals. So first, let's review some old vocabulary. So first, the entire collection of units about which we want information is called the population. So you might care about all eligible voters in America, or you might care about everybody in America because you want to know what proportion studies from allergies. So the fixed summary number associated with the population, this is a population parameter. This could be a p, a mu, mu1 minus mu2. That's the unknown value that you can't find and you want to estimate. The collection of units that actually get measured is called your sample. And the sample size is the number of units in your sample. This is denoted by the letter n. And the summary number computed from the sample that's used to estimate the population parameter is the sample statistic. And this is some stuff like p hat, x bar, etc. In each part of this question, explain whether the proportion that is described is a sample proportion or a population proportion. In the 1990 U.S. Census, it was found that about 1 in 9 Americans were at least 65 years old at the time. Well, because we're talking about the census, we're going to assume that all Americans were measured. So this is as close as you can get to a population proportion. And the population proportion we found was p equal to 1 out of 9. In a clinical trial done to assess the effectiveness of a new medication for asthma, a satisfactory relief from symptoms was experienced by 55% of the 80 participants. This is obviously a sample proportion. P hat would be equal to 0.55. A Gallup poll surveyed a random sample of 439 American teenagers. One question that they were asked was, how strict are your parents compared to most of your friends' parents? The choices were more strict, less strict, and about the same. The choice more strict was selected by 171 of the respondents. So what is the population of interest, or what is the group that you care to have information about? Well, we asked American teenagers, so the overarching group we care about is the group of American teenagers, so all American teens. And I suppose American is a proper noun and should probably therefore be capitalized. Oh, English. All American teens. What is the population parameter of interest? So make sure you specify if we're talking about a proportion or a mean, but we're looking at the more strict choice. So this is the proportion of American teens who rate their parents as more strict. What is the sample? Well, the sample is the n equals 439 teenagers who were polled. And what is the value of the sample statistic? Make sure you use proper notation here. P hat equals 171 out of 439, which is about 3.39 or 339%. And this is just quick review of what we did in Chapter 5, but a 97 Gallup poll said that 57% out of 469 teens who date said they had been on a date with someone of another race or ethnic group. Find the margin of error for 95% confidence interval was given as 5%. Find this confidence interval. Well, the confidence interval is given by the proportion plus or minus your margin of error. And that is 57% plus or minus 5%, or 52% to 62%. And what we're going to focus on in this lesson and the next lesson is how to find the margin of error. Back in Chapter 5, we used this 1 over root n formula for margin of error, and we are going to learn a more refined version for proportions, and then also what the margin of error is for means in the next unit. So first of all, let's talk about what does that confidence level mean. So the confidence level describes the chance that an interval contains the true population value in the following sense. Most of the time, quantified by the confidence level, intervals that are computed in this way will capture the truth of the population. If we consider all possible randomly selected samples of the same size, the confidence level is the fraction or percentage of those samples for which the confidence interval would include the population parameter. So for example, if you have a 95% confidence level, it means 95% of your confidence intervals are going to cover the true population parameter. And some of them, the unlucky 5%, will not. The goal is to estimate the population parameter with an interval of values that we are fairly confident covers it. And because our confidence intervals would cover this most of the time, we can be pretty sure that our confidence interval we find does cover it. The method we're going to discuss is more accurate than the 1 over root n estimate that you found in Chapter 5. So here is the general formula for a confidence interval. You take the sample statistic, which in our case is usually p hat, plus or minus the multiplier times some standard error. And this whole thing was 1 over root n in Chapter 5. The multiplier is a number based on the confidence level desired and is determined from the standard normal distribution, or this should actually say z distribution for means. So the 95% confidence interval for one proportion. So first you find the sample statistic, and that is the sample proportion, which is denoted by p hat. The appropriate multiplier is 1.6, but you think 95% confidence, that's 2 standard deviations, so we just go ahead and usually use 2, because 2 is close enough. And the standard error of p hat is root p hat 1 minus p hat all over n. And remember that standard error of p hat is an estimate of the standard deviation of p hat. So a CNN time poll of 1,003 American adults, which was conducted by telephone, was designed to measure beliefs about apocalyptic predictions. One of the results reported was that 59% of the sample said they believe the world would come to an end. I think that was in their lifetime. So first, find the standard error of the sample proportion who believe that the world will come to an end. So the standard error of p hat is equal to the root of p hat 1 minus p hat over n. And notice that p hat is the sample proportion, or 0.59, and n is the sample size, 1,003. In between those values, we have 0.59, 1 minus 0.59, all over 1,003, which is approximately 0.0155, which, if we're going to use 3 decimal places of accuracy, is about 0.016. So find a 95% confidence interval for the population proportion. Interpret the interval in the way that could be understood by a statistically naive reader. So the confidence interval is given by the proportion, plus or minus our multiplier, times the standard error of your proportion, which is 59% plus or minus 2 standard deviations, times 1.6%. 59% plus or minus 3.2%, which is 55.8% to 62.2%. Okay, now our interpretation is that we have a certain amount of confidence that our true proportion falls within this interval. So here's how you write that. With 95% confidence, we can say, or we have, that the true proportion of American adults who believe the world will end is between 55.8% and 62.2%. Now notice that in the width, or in the interval, the width is affected by a few things. It's affected by this number and by this number. So here's how those things are affected by both sample size and confidence levels. So first, the sample size helps determine the width of the confidence interval. So larger sample sizes produce smaller intervals because the standard error of a statistic decreases when the sample size increases. Of course, what I'm assuming here is we're keeping the confidence level the same. But if you make a bigger sample makes smaller standard error, which means you have a narrower interval. Next, the confidence level. More confidence means you must use a bigger multiplier. Think that we're more standard deviations from the mean. Higher confidence levels produce bigger or wider intervals. And lastly, the natural variability among units also affects the width. More natural variability results in wider intervals, i.e. as p hat approaches 0.5, the standard error gets larger. And when p hat is 0.5 exactly, you end up with that 1 over root n formula we used in chapter 5. And here's why. That 1 over root n formula was specifically about a 95% confidence interval. So our multiplier is 2 times the standard error of p hat. So 2 root p hat, 1 minus p hat over n. Well, if our p hat is 0.5, that's 2 times the root of 0.5, 1 minus 0.5 over n. Well, that's 0.25. So 2 times the root of 0.25 over n. And well, that's 2 times the root of 0.25 over the root of n. Well, root 0.25 is a half. 2 times a half is 1. We get 1 over root n. And if the p hat is either bigger or less than 0.5, this guy is always an overshoot or a bigger estimate. And we can explain that with an example. So suppose a Gallup poll is conducted with 1,000 people, and suppose that p hat is 0.1. Compute and compare the conservative margin of error, this is from chapter 5, to the 2 times the standard error of p hat. So in this case, we would have 1 over root 1,000, which is about 0.032. In this case, we would have 2 times the root of 0.1. 1 minus 0.1 is 0.9 over 1,000, which comes out to be 0.019. This guy always overestimates that guy, or is always a bigger margin of error. So suppose that a survey is planned to estimate the proportion of a population that is left-handed. The sample data will be used to form a confidence interval. Explain which of the following combinations of sample sizes and confidence interval will give the widest interval, which is likely to give the narrowest interval. Okay, so things that make your interval wider. Your interval is wider if you have a smaller sample. Okay, well that makes these two candidates for a wider. And your interval is also wider if you have a bigger multiplier. So of those two, 95% is going to have the bigger multiplier. So this is going to be the widest. Okay, things that make it narrower. That would be a larger sample. And also a lower multiplier, which is a lower confidence level, which means that this guy is going to be the narrowest. Less certainty means you can have a sort of smaller target. Okay, confidence intervals for population proportions. So in this lesson, we're going to find confidence intervals in a more general sense, as in prior to now, we only know how to find a 95% confidence interval, but after this lesson, we will find any percent confidence interval that we want. Recall, in general, the form of a confidence interval is your sample statistic plus or minus some multiplier times your standard error of your sample statistic. In this case, our sample statistic will be p hat plus or minus some multiplier times the standard error of p hat. And here are some common cases and their corresponding multipliers. So 90% confidence, the multiplier is 1.645 or about 1.65. 95%, it's about 2, and you can think, oh yeah, 95%, 2 standard deviations is about the mean. 98%, 2.33. So, it's not quite to 3 because we're not at the 99.7 yet, but it's going up. 99%, we're at 2.58. And then you see you have the general confidence interval form on the right. And we'll talk about where those numbers come from in just a teensy bit. So in a CBS News / New York Times nationwide poll done in 2009, the proportion of respondents who thought it should be illegal to use a handheld cellular telephone while driving a car was 0.8. The poll's sample size was 829. So find the value of the sample proportion and the standard error. Well, the sample proportion is the proportion who thought that using a cell phone should be illegal. Well, that would be 0.8. And the standard error of p hat is given by root p hat 1 minus p hat over n, 0.8, 1 minus 0.8 over 829. So this is about equal to 0.014. or 1.4%. And notice that 0.8 is the same thing as 80%. Find a 95% confidence interval estimate of the population proportion who think it should be illegal to use a cell phone while driving. Well, this would be our population proportion plus or minus our multiplier of 2 times our standard error of p hat, or 80% plus or minus 2 times 1.4%. So 80% plus or minus 2.8%, or 77.2% to 82.8%. Now, what should happen if we increase the confidence level 98%? Well, our multiplier will change and it will become bigger. We can have 80% plus or minus 2.33 times 1.4%, or 80% plus or minus 3.262%. Just rounding to the nearest tenth, that's going to give us 76.7% to 83.3%. And which interval is wider and why? Well, the 98% confidence interval is wider. Because the multiplier is larger. So there are a few conditions on using this confidence interval for a proportion. Condition 1 is that your sample needs to be randomly selected from your population. Think about all those horrible stories of stuff done badly. And both n times p hat and n times 1 minus p hat should be at least 10, which is saying that the number of things in each category is bigger than or equal to 10. Now, next, let's talk about where those confidence interval numbers come from. Like, how did you get the multiplier of 1.96? So these things come from a z-table. So, for example, suppose we want to find the multiplier for a 95% confidence interval. If you're looking at 95%, you have this standard normal bell curve, and the area underneath it, 95% confidence means this area is 0.95. Leaving 2 2.5% in each tail. So this guy has area 0.025. This guy has area 0.025. Now what you do next is look at the negative half of your Z table. And what you're going to look for is you're going to look in the bulk of the table for 0.025. Search through there until you find 0.025. And then what you're going to do is a little bit backwards. You're going to tell me what Z value gives this. So if you do that, if you look, you end up looking in the negative side. You look in the 1.9 row, and you see that you have 0.287, 0.281, 0.274. They're going down to 0.025. And you see that 1.96 is 0.0250 exactly. So a Z value of negative 1.96 is what comes out. And you can see there that to find the multiplier is the absolute value of the answer you just got. Or in this case, our Z star is 1.96. So what you do is you kind of reverse this. Instead of me giving you the Z and you finding the P, you have the P and you find the Z. That's the opposite direction of before. Okay, let's do one. Determine the value of the Z star multiplier that would be used to compute a 97% confidence interval. So here's the general picture. Okay, you have 0.97 area in the middle, leaving 0.3 left over, or 0.015 over here, and 0.015 over there. Okay, so we have, look for 0.015 in your table. And it should be a more negative number than negative 1.9. And you see it's negative 2.17. So your Z star is the absolute value of negative 2.17, or 2.17. And a higher confidence level should have came out as a bigger value, so there you go. Okay, well, what is the confidence level that's been computed as simple proportion plus or minus 1.28? Okay, so what we're going to do now is we have the Z value. Look up negative 1.28 in your Z table. Negative 1.28 has a corresponding p-value of 0.1003. So what that means is that the area in one of your tails is 0.1003. And so the area in the other tail is also 0.1003. Okay, well that means the total in the tails is twice that, so 0.2006. Your confidence level is area in the middle. Which is given by 1 minus 2 times 0.1003, or 1 minus 0.2006, or 0.7994, which is about 80% confidence level. And one last explanation of margin and error. So the difference between the sample proportion and the population proportion is less than the margin error 95% of the time, or 95% of your samples. And the difference between the sample proportion and the population param is more than the margin of error, about 5% of the time. In other words, for most sample estimates, about 95% of them, the actual error is likely to be smaller than the margin of error. Occasionally, about 5% of the time, the error might be larger than the margin of error. That's if we have a 95% confidence level. So suppose that the margin of error for a sample percentage is reported to be 3%. What is the probability that the difference between the sample percentage and the population percentage will be more than 3%? Assume we have a 99% confidence interval. So in this case, what is the probability that the difference between the sample percentage and proportion will be more than 3%? There is a 1% or probability of 0.01 that the difference is more than 3%, or in almost all samples, the difference will be less than 3%.